Hi, it's Ms. Carpenter. Today we're going to start our new unit, so let's see what's in the box. First of all, we have some socks. These have some old school glasses that you might not recognize. They're 3D glasses because what we're going to be doing is 3D. What else is in the box? Aha! We have this little guy, a little set of blocks. And our last thing is this, which I've drawn out here on the board. So this is a rectangular prism. What we're going to be doing now is our unit on 3D surface area. So when we look at surface area, we want to think about, we're not doing volume. What can go inside the box, and it is a box in this situation, is not what we're concerned with. We want to know what the outside is going to be. And an example of that is when you would go and you get yourself something, you're going to give a present to someone, and you have to cover it with wrapping paper. Now, if we were going to cover this with wrapping paper, we'd wrap it and it would overlap. But we want to know what it would be if it were just covered. So if you can imagine taking wrapping paper, literally taking wrapping paper and covering every side. Well, you might take a rectangular prism like this and really examine it and say, okay, well, how many sides or faces am I going to have to cover? So these are called faces in French and in English, les faces. Here we have at the corner where the faces meet, we're going to have a vertex, or in French, a sommet, just like you would have at the top of a mountain. And then on the edges, in English we just call that an edge, and in French we call that arête. So we have these pieces of vocabulary that you need to know. Face, sommet, arête, face, vertex, edge. That will help you greatly. And what we're talking about, the shape we're talking about, is a rectangular prism, or a prisme rectangulaire. So what do we have when we have this guy? What is on it? What do we have to concern ourselves with? Not the inside, but we do have to concern ourselves with, we look at it, and we have to make some decisions. So we're going to call this the top, this the bottom, this is going to be the face or the front, this is the back here. On this side we have a side, and on this side we have a side. So as you can see, we have 6 different things that we have to measure. The top, the bottom, the left, the right, the front, and the back. In French, on dit dessus, dessous, gauche, droite, avant et arrière. Puis si vous utilisez ça, ça va vous aider beaucoup. So if you use this is going to help you greatly. And I know this video is for parents as well, so we're going to do it in English, but I just want to give you the vocabulary in French as well. The other videos we will do in French, we'll be using this vocabulary, so I'm going to get you used to it right away. But the big thing is if every single time you remind yourself, I need, with rectangular prisms, to look at the top, the bottom, the front, the back, the left, and the right, it will help you to keep track of everything. And I encourage you to actually write this down with your values. So when we're looking at a rectangular face like this, how do we find the area? Well, you'll remember from past math lessons that we would take a length times a width. And that's not something you have to memorize because we know area means how far do we go from here and how far do we go from here, and when we multiply those together, we're going to get an area right here. And the cool thing is when you're doing a rectangular prism, every single side is that. So you know I'm not big on forcing kids to memorize formulas. I'd rather you learn them because you are getting so used to them because they make sense and you understand them completely, and then you use them, and it's a facility after a while. Okay, I'm going to call that L times W because I know that when I multiply the length and the width, I get this area. So again, it's surface area, so we're going to be wrapping. So let's wrap this up and actually see what kind of surface area we're going to get. Okay, so I've started wrapping our gift. And I've done it so that we use the two-sided wrapping paper so that you can really clearly see which is which. So let's start with the top. This is the top of the box, and the bottom of the box I've done in polka dot. Now the top and the bottom are going to have the exact same dimensions. So let's measure those out. We get 26 by 10. So our measurement for this guy, and I'm going to show you how to do it. So you want to say top bottom. The top bottom is going to be 26 centimeters by 10 centimeters for a total of 260 centimeters squared. That's our area. That's our surface area. But we have two of those. So you can decide to do this, and that'll be top bottom. Or you can say 260 plus 260 equals your top bottom. You decide how you want to do it, doesn't matter as long as you get it done. So what are we going to have? Well, we know that 60 plus 60 is 120, plus 200 and 200, which is 400. So it'll be 520 centimeters squared. And it's squared because you're literally squaring it. You're multiplying that side by that side. In this case, it's a rectangular prism. So it's longer this way than it is this way. Now, if you look at my earrings, I have cubes. Today, because I wanted to remember to tell you, with a cube, of course, this edge and this edge will have the same length. You will multiply them, you'll get an area for your face, and you have 6 faces that are the same, so you can just multiply it by 6. Okay, so we have our top bottom, we know what that is. Now with a rectangular prism, it's great because everything's in pairs. So we can say top bottom. Now we can do left right. Then we can do front and back. It's not the same when you have a cylinder or if you have a triangular prism, which we'll get to in our next part. So we're gonna have one of our sides, and there's the other side. So we have left and right. And I'm actually just gonna take the left one off and show you that it's exactly the same as the right, which is great. So now we have to measure this guy. We measure it out. We see that this is 10 centimeters, which makes sense, by 8 centimeters. So this is 10 by 8. So this is our left and our right. So we can just write LR is a 10 centimeter by 8 centimeter measurement, which is going to give us 80 centimeters squared. But we have 2 of them. So really it's going to be 160 centimeters squared. And what I do, and you guys know I love color, I always do this. Top, bottom. Left, right. Because in the end, when you're adding this all up, you have a lot of numbers. So in order to keep track of them, if you put them in these little clouds or a box that's another color and you label it, you're going to know at the end, okay, we've got a whole bunch of stuff here, but these are the only things I have to add up in the end. So did you notice that our left and right had a similar measurement, or the exact same one? It had a 10 centimeter part of it. So why was that 10 centimeters and also 10 centimeters here? Well, of course, they share the same edge. So this has to be the same. But it's interesting because this part was 8 centimeters and we haven't seen that yet. So I wonder what's going on. Well, then we look at the front and the back. And the thing is that you can often have this rectangle be a completely different measurement than your top and bottom. Your front and your back aren't necessarily exactly the same. So let's just lay this one out so that you can see compared to this guy. Can you see? There's a difference. There's a good difference there. So this guy is going to be smaller than the top and the bottom. So if we look at that front, one of these measurements should be the same as this guy. And that's a way you can check your work. And sure enough, when we measure the front, we're going to get 8 centimeters right here. So our front and our back will be an 8 centimeter. And then what do you think this will be? Measure it just to be sure. 26 centimeters. It better be 26 centimeters because you have a measurement that is following the exact same edge. So they should be the same. So then you look back and you take your box and your wrapping paper and you say to yourself, okay, I should have 6 sides, faces. They're in pairs that should be the same. So these numbers just double, 80 twice. What's 8 times 26? So you can do that either with your calculator or you can do it using calculation. So 6 times 8 is 48, and 8 times 2 is 16, plus 4 is 208. Or you can say 26 times 10 would be 260. Take away, because we wouldn't have 10 of them, we'd only have 8, so take away 2 of those 26. So take away 26 and take away 26, and you're going to get 208. Okay, However you want to do that is fine. So now we have a number here for 208 centimeters squared. Make sure you include your units as centimeters squared. Now we need to double this, don't we? Because we have 2 of those faces. The other thing to check your work is to say to yourself, okay, I'm looking at the box. I can tell that this is larger surface area than that. So it obviously should have a smaller surface area. It's not much smaller though. So we would expect it to still be in the 200s. So if this guy was 260, and this guy is 208, that's logical. So again, math is logical and it's finding patterns. So just keep going through it as you're doing it and say to yourself, does that make sense? So I'm gonna multiply this guy by 2 this time. And what would we get? Well, 2 200s is gonna be 400, and 2 8s is 16 centimeters squared. All right, and what was that? That was the front and the back. So we've got top, bottom, left, right, front, back. You add them all together and you'll have your total surface area. Now nobody wraps presents like this, but normally when we're in the classroom, I get my students to cut these out and to wrap the gifts so that they can compare them and have a really true understanding of how this works. So if you have a birthday or something coming up, try it. Try wrapping it exactly and just experience what it's like to find that actual surface area. Okay, that's an example. We're gonna do one together that includes some odd shaped, an odd shape. So we've got, this time it's not just a rectangular prism. It's a figure that has, and I want you to ignore the little part that would be inserted into the next block. We're gonna pretend that that doesn't exist. And this is just gonna be 1 unit by 1 unit. So these are cubes, but there's more than one of them put together. So how do we tackle something like this? Okay, so let's do this one together. So it's gonna be the same idea because we're still using rectangular prisms. Oops. Except this time, and this is straight from the notes that I've sent out. So this is exactly this guy right here. So we're looking at the notes. This is our, and sometimes it's hard to imagine what this means. So I'm gonna actually use this one as the first one to give you some ideas of how to tackle it. So let's have a look at this guy. So what do we wanna start with? Well, let's start with top and bottom. So the top and the bottom, what do they look like? Well, we have the luxury of actually turning it and looking at the top. And I'm gonna draw that. So we have a cube here that's sticking up, and a cube here, and then we have a cube here that's sticking out like that. Okay, so that's the top. What does the bottom look like? Let's flip it around, and hey, the bottom looks exactly the same. This one should be a little bit bigger. So and that makes sense. The top and the bottom are the same. You can tell just by looking at them, and you're not covering, in French we say the chevauchement, in English we say the overlap. I mean, you're not going to wrap that, you can see there's a blue block in here. Well, you're not gonna wrap the blue part of the block because it's covered by this brown one. So when we look at the top, we're talking about this surface, this surface, this surface, and this surface that we're going to cover. On the bottom, we could cut out a piece that would be like this, but in the end, they're the exact same surface area. So this is a 1, 2, 3 by 1 unit right here. So this part right here, the blue is going to measure 3, because 3 times 1 is 3, and so is this. But then we also have this guy, which is a 1 by 1, so this guy is going to measure 1. So if we had to cut out wrapping paper, we would need 4 solid units of wrapping paper for each. So the top and the bottom together are going to measure 8 units squared. Okay, let's look at the front. The front, well, isn't that interesting? We have 1, 2, 3, 4 again. So again, the front, which we're going to use front back now. Front back. The front looks like this. And this guy sticks out a bit. And the back looks like this. So again, we have 4 units. And it won't be the same with every single shape that you have, but in this case it is. So we have 1 by 1 and 1 by 1, 1 by 1, 4 times. So this is a 4 and this is a 4. And in total, your front and your back are going to measure 8 units squared. And I'm demonstrating another way to do the calculations and keep track of them. You can do each one in different colors. So the top bottom is blue, the front back is red. That'll help you keep track. We still have one more. We have to do the left and the right. So sometimes they're not all going to be like this, where they'll all be the same, so you really have to pay attention. Okay, so what does the left and the right look like? 1, 2, 3 units, and they look like this. This one sticks out farther, and this guy goes this way, and this is the left and the right. And then when we flip it this way to look at the other side, it's the mirror image. Okay, so you can easily tell that we have 3 units here, plus 3 here, so this will be 6 units squared. So have we done every surface? We have done the top, the bottom, we've done the front, the back, and we've done the left and the right. That makes it easier for you to keep track, because if you start counting, okay, I've got 1, 2, 3, okay, wait, did I count that? Hold on, 1, 2, 3, okay. You'll get confused. But if you do it from a perspective of one part at a time, it'll be easier to keep track of and to calculate. So now we would add these all up. We've got 16 plus 6. That gives us 22 units squared, and that would be our total surface area for this particular set of blocks. Okay, let's try a question. So from Travaillant, we have question number 3. I like this question because it forces us to really think about every single part that we would wrap if this were a gift. If we're just looking at sides, we might forget some sides. So let's look at it from a whole perspective of I'm going to wrap this. So the first thing I notice is that there's an extra slab on the bottom. There are 2 here that are the same, and there's a big space in the middle. So just take stock of what you have. The units are centimeters. Now what I would do, approaching this problem, the first thing I would do is label again some of the things that aren't already labeled. So we know, because these are rectangular prisms, that these would both be 15 here. And these would be 15. So if this is 15 and this is 15 and the whole thing is 50, that's 50, take away 30, because 15 plus 15 is 30, and that gives us 20. So this would be 20. You can write in the centimeters. I'm not going to, just to keep it a little simpler. We know they're all in centimeters. Then we know this is 30, so this is also 30, and that means that this is also 30. Why am I doing this? Well, because when I go to calculate, it's a lot faster for me and more accurate if I already have it labeled. So what about this? This is going to be 5, and this is going to be 5. What about this guy? This is going to be 30, and this is going to be 30, and this is going to be 30. Just because we know that these are rectangular prisms and they share edges, which means that they share measurements. Is there anything else that we don't know? Nope. We've got lots of sides labeled. We see that 45 starts here and ends here before the final slab, which means that this guy is 45, this guy is 45. And you don't have to do all of these. That's a lot. But I've just, for the sake of making it extra clear for you, I've put them all in this time. Okay, so what do we need to know? Well, we need to know the top and the bottom. So there are different ways you can do this. But if we look at the top, it's that and that. If you can imagine that you're looking down on it, and this. Is anything else going to be visible if I'm a bird flying above and I'm looking down? Another way to think of this is that I'm painting this whole thing. So I'm painting all of this, although in this case we're going to count the bottom as well. If this were just a building, we obviously wouldn't be painting underneath. So I've labeled the top and the bottom, or I've colored them in. And I'm doing that to make it really clear for myself. Okay, so let's start with that. There's nothing else we can see from the top. And why am I saying that the bottom is the same? Well, in this case, if you can imagine taking this and pushing it down like a button and pushing this one down like a button, and this were flat, you'd have a 30 by 15 here, a 20 here, 30 by 15 here, and you're gonna have the exact same thing underneath. On the top, it's gonna look like this, right? This is this, and this. That's what you have from the top. But on the bottom, it's just gonna look like this because it's flat and it's all one piece. But let me just come over here so I can make sure I make these a little bit more accurate. They should be identical, the top and the bottom. That's why I can do them together. So knowing that, I don't have to calculate 15 times 30, 15 times 30, add those together, 20 times 30, add those three together, and then do the bottom. All I have to do is say 50 times 30 underneath. If you can imagine looking up from the bottom, you've got a 30 here and a 50 here. So this is 30 and this is 50. Well, 5 times 3 is 15, and you've got 2 zeros, so that's going to be 1,500 centimeters squared. Well, let's pretend I didn't realize that I could do the same thing, because this is going to be equal, and this is going to be 50 times 30 as well. And let's actually calculate each part. So we've got 30 by 15 here, so this side is 30, this is 15. This is 30, this is 15. We already said this is 20, and this, of course, will be 30. So if we do 30 times 15, well, if we do 3 times 15, that's going to give us 45, so we'll have 450 centimeters squared, and this will be the same because it's the same numbers. All right, those two together, 450 plus 450 is 900. So far we have 900 plus 20 times 30. 20 times 30, or 2 times 3 is 6, so 20 times 30 is 600 centimeters squared. So now we have 900 plus 600, which of course gives us 1,500 centimeters squared. So now we've just done a little mathematical proof. Yeah, the top and the bottom are the same. So the top and the bottom each measure 1,500 centimeters squared. So together we have 3,000 centimeters squared with the top and the bottom. And you can pause the video at any point to try these on your own. I encourage you to try them on your own. Okay, what's next? Well, we've done the top and the bottom. I'd like to do the front and the back next because they're the simplest next part. So we've got the front, and because this figure is exactly the same on the back, once again, the front and the back will be the same. And in this case, they will be identical. They will look exactly the same front and back. So the front and the back, we have this slice right here. What's that going to measure? That's going to be 5 times 50. Okay? So what are 5 50s, or what are 10 25s? 250 centimeters squared. Then we're going to have this guy, which is going to be 45 times 15. And this guy, which is also going to be 45 times 15. So these will each be 675. So 675 and 675. So we have 675, 675, and 250. Let's add those all up. And we're going to have 1,600 centimeters squared. Okay, so 1,600, but that's only one side. And at this point, you can stop yourself and say, okay, let's just make sure I have this correct. Okay, so if I had 50 cents and I added 75 cents, that would be $1.25. Another 75 would be $2. Okay, that makes sense, $2. Plus I'd have $12, that's $14. $15, $16. Okay, that makes sense, 1,600. Or however you do this. Okay, so I've got 1,600, but that's only one part. That's only the front. So I have to have another one of those for the back. And just check with yourself every time. Did I do 2 of them? And did I add those up? And is this the total for both? No, it's not. Okay, so we're going to add those together. We know 16 and 16 is 32. So it's 3,200 centimeters squared. So now we have the top and the bottom and the front and the back. What have we got left? Well, of course, we have the left and the right. And this is where it comes in so handy to have colored these. Because then you say, okay, well the left or the right, depending on how you want to think of it, the side is this, and the other side is from here. But if you were painting this or you were wrapping this, you would suddenly realize, oh, whoa, 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 wait, there's also this. So this is what I mean by you have to have X-ray vision. If you're looking from this one side, you have to realize, oh, there's also that part. So you have to add this and this, okay? So you look through and you say, what parts would I be doing that I haven't done yet? And see, because I've colored it, I notice, oh, I have to add that one as well. Okay, so what have we got here? We've got a 30 times 5. So we're doing the left and the right. And you can see you need lots of space for these questions. So let's do that, and it really comes in handy to do it in color. But anyway, okay, so 30 times 5. So let's start from the bottom. 30 times 5. What do we have? 5 30s, 5 groups of 30. That's going to give us 150. Or 3 times 5 is 15, and put the 0 at the end. So we've got that plus 45 times 30. So 45, 45, and 45 would be 3 45s. That would give us 3 5s are 15, 3 4s are 12, and one more would be 13. But we're not doing 45 times 3, we're doing 45 times 30, so we're going to add that 0. Another way to do it is to say 10 times 45 would give me 450, and I have 30 instead of 10, so I have to do it 10 and 10 and 10. So that would give me 450, 450, and 450. If these were 500s, they'd be really easy numbers, and it would be 1500. They're not, they're 50 less, or 150 less in total. So 1500 take away 150 would give you 1350. So you can just check your math in every which way. I know you're gonna use calculators, but this is great for your brain. So if you have time and energy, do it this way. Okay, so we have that section. We have this guy. Hold on. What do we know about this? It's exactly the same as that, 45 by 30. So now we have all of those, and we just add them up. So 350 and 350 is going to give us 700. 700 plus 150 will be, or 700 plus 100 will be 800, plus 50 will be 850. And then we have 2 in the thousands place, so 1, 2, 2,000. So we have 2,850. Let's see if that makes sense. 2,000 plus 100 plus 300 plus 300 would be 2,700. But then we have another one here, which would be 800. And we have 50 left. Yep, 2,850 makes sense. What does that measure? That measures this, this, and that. So we've got the entire, depending on if you're looking at it from this side, left side. So we'll call it the left. So we can put that in, 2,850 centimeters squared plus 2,850 centimeters squared. Where did I get that second 2,850? I just came over here and went from this side. And of course there would be this part that we can't see, there would be this part that we can't see, and this part right here. Now we have to think to ourselves, is everything colored? Well, everything we can see is colored. Did we double? We sure did. So what would these be? Well, we've got 50 and 50, which is 100. Then we've got 800 and 800, which is 1,600. And then we've got 2,000 and 2,000, which is 4,000. So we've got 4,000, 5,700. Oops, 5,700 centimeters squared. If you want to check it another way, you can say, okay, I've got 4,000. I've got 800 and 800, plus, which is 1,600. And we got 50 and 50, which is another 100. 4,000, 5,000, 700. Okay, then you take each one of these guys, add them up, and you get your final answer. So all of that, we still don't have the answer. So this total surface area, and you could use this if you were painting this, whatever this is. You would have to say, okay, well I've got, let's see, I've got 5,000, 3,000, 3,000. So that would be 11,000, right? 6 and 5. I've got 11,000. Then I've got, in the hundreds place, I've got 2 and 7, so that's 900. And then what else do I have? Nothing. So our final answer, total surface area is 11,900 centimeters squared. And that is the correct answer. Okay, now that we've done rectangular prisms and we've put a bunch of them into a composite object, let's move on to the next kind of composite object. Okay, for our next part of 3D surface area, we are going to study cylinders, triangular prisms. What else is in here? I forget. Oh yeah, sushi. Sushi socks to represent different shapes of cylinders. And other than what's in the box, on my shirt I have triangles and they're touching each other like this. One is here and the other one is here. And that's to remember that on the end of each triangular prism we have the same triangle. It doesn't necessarily have to be an equilateral or an isosceles triangle. It can be any kind. And then, oh yes, one last thing, my cylindrical necklace to remind us about cylinders. So I just want to take a quick second to go through this. So if you can imagine that, once again, we're painting a surface. We're not worried about the volume. So if we take a cylinder and we open it up, of course we have 2 circles on either end. But what about the rest of it? A lot of students get hung up on trying to figure out, okay, well now I have the circumference of this circle, that must be important here. Well, it is, except that when you take this part of the cylinder, it's actually a rectangle. So it's like having a piece of paper, and I often use this guy in class to explain. So if you can imagine, you've got your cylinder, and we have our 2 ends that are circular. And then when we take the cylinder apart, it's just a piece of paper, or a rectangle, square, depending on the shape. And so you can do your length times your width like you would with any regular rectangle. And then of course for our circles, we have to remember that to look at this, the circle part is actually the circumference, and the area is going to be a disc. So it's that whole surface area, the disc, that we have to measure. And to find the surface area of a disc, we are going to use that radius. So if you imagine the very center of a circular disc, and you make a rays like the sunshine from it, you will have the same distance all the way around for every single ray. And those rays are the important part that we need in order to measure the surface area. And then we use that really wonderful pi, 3.14. And when you're calculating, you can use, on your calculator, you can use the button pi, or you can just use 3.14. You're going to square the radius and then multiply it by 3.14, which gives you the ratio of how much bigger the circumference will be. Also, why do we need the circumference? Well, that's the surface area, but the circumference, or the circle part, the outside part, will give us the exact what? It's going to give us this length, isn't it? Because it's exactly the same as the outside of the disc or the circle. When you open it up, ta-da, this is the exact same as the circumference. And we know that the circumference, or the outside of a circle, is measured using the diameter. And so whatever the belt of the circle is, or the equator, or the center, the diameter, the largest line you can draw from one part of the circle to the other, that central line multiplied by 3.1415, etc., will tell you how long this distance will be. And that circumference is really important, again, because it tells us what this length is. And then we can use that to figure out this part. Okay, so let's do with our triangles. If we look at a triangular prism, before we can even get to that, we have to talk about triangles. So in case you forget, a triangle has a formula of base times height divided by 2. Why is that though? You know, I don't like memorization of formulas without understanding. So if we can imagine, what is the base? Well, the base is the bottom, I, times the height, which is from this point, this vertex, this sommet, down to the base. So whatever you've determined the base to be, because you could have used this as the base and this as the height, you could have used that as the base and that as the height. All you have to make sure that you do is that once you've decided what the base is, that you then find the point that is across from it, and you draw a line that makes a 90-degree angle with the base. So to find the height, this has to be a 90-degree angle with the base. So here's our height of this triangle. Our base measures 28.5 centimeters. Our height is 22.5 centimeters. This is not our height. This has a different measurement. This has a different measurement. They will not be the height. The height is only this. So this measurement right here times this divided by 2 will give us the surface area of the triangle. But why does this work? Okay, so imagine that you had this as the base once again, but then you turned it into a rectangle all the way around it. So how are we going to do that? Well, we're going to keep the exact same measurement for the base, but instead of just looking at our triangle, now we're going to make it into a rectangle. So what does a rectangle have? 4 90-degree angles at each corner. So we make a 90-degree angle right here, whoop, and we measure this. Well, of course, it's going to be exactly the same as this because they're both at 90 degrees. They both go straight up, and they both measure the entire distance from the base to the top of the triangle. So 22.5 is our measurement here. So if we do 28.5 times 22.5, we're doing the same thing we did with the triangle, except if we don't divide it by 2. But why do we divide base times height by 2 when we're measuring the surface area of a triangle? Why do we do that? Well, that's because if we were to take that triangle and turn it into a rectangle, you would actually double the surface area. So this surface area is equal, exactly the same as this plus this surface area. So I want to do a mathematical proof with you, just so that we make sure we understand this. So this triangle, which is the black one, I've redrawn the height and the base, I've multiplied them, and then I've divided by 2, and I get 320.625 centimeters squared. That is the area of this triangle. Okay, what is the area of the rectangle if we took all of it? The area of the rectangle is 28.5 times 22.5, length times width. That's going to give us 641.25 centimeters squared. Well, what do we notice about this number and this number? This divided by 2 is that. So this is half of that number. So far so good. So far it's showing me that, oh yeah, half of this entire rectangle would give me the measurement of the triangle inside of it. But I want to make sure that it actually is true that these two are going to measure to be double. Now, of course, it logically stands to reason that they would be, but we still in math like to prove things. So let's prove it. So the blue one is going to be your 22.5 right here. It just happens to be the same as this guy. If this were just a little bit more this way, that would have changed. But right now, this one's going to be, this is an actual isosceles triangle right here. No matter. So this distance from here to here is that amount, and from here to here is 6. And together, they equal the same as this, obviously. So this distance times the height, which because this is a right angle, is the actual part of the triangle here. We don't have to redraw the height. This times this, divided by 2, will give us the area of this triangle. So 22.5 times 22.5 divided by 2 is 253.125 centimeters squared. That's for the blue. What is it for the pink? Well, it's 6, and because this is a right angle, this will be our height. 6 times 22.5 divided by 2 is 67.5. Well, if we take this plus this, we are going to have the same as this. 253.125 plus 67.5 is 320.625. So this area is equal to this area, which means that the reason we do a triangle as base times height, which in this case the height is right here, but base times height, which would just be the rectangle that would go around it, the reason we divide it by 2 is because the area outside of the triangle and the area inside of the triangle will be exactly equal, and this is half of a rectangle. So we know that a rectangle is base times height, and a triangle is just half of a rectangle, okay? So that's why it's base times height divided by 2. But let's take them out of the shape and let's have a look. What do we know? Well, it doesn't matter right now that that's 11 and that's 17. What we need is the base and the height. So base times height divided by 2 that is our area of this triangle. Because we have 2 of them, well, we didn't actually have to go and take it and divide it by 2, did we? Because we have 2 of them. So in the end, we could have, instead of saying, okay, now we have to go 90 plus 90 is 180 centimeters squared. Well, we could have just not divided by 2. But until you get used to it, you may want to do base times height divided by 2 equals, in this case, 90 centimeters squared. And remember that you have 2 of them. So with an object like this, you're going to have triangle, area, and you're going to have 2 of them. 2 times triangle. So our triangle area, once again, was 20 times 9. 2 times 9 is 18, so 20 times 9 is 180. Divided by 2 will give you 90. 90 plus 90, 180. Oops, 180 centimeters squared. So there's our 2 triangles. What about our rectangles? Here's what I would suggest you do. First of all, look at this rectangle that's right in front. It's the easiest one. So what you'll do with this guy is you'll say, okay, well, this front part right here, I have a face here that's 24 by 20. So this guy, he is 24 times 20. All right, well, we know that 10 times 24 is 240. So if we did that twice, we'd have 240 plus 240, which is 480 centimeters squared. So 24 times 20 is 480 centimeters squared. That's the area of this guy. Okay, so what do we have to make sure that we have? It's kind of easier if, in this case, you put a little sidebar where you write everything that you're going to add up at the end. So now we have this guy. This guy's going to be 480 centimeters squared. Okay, let's do the next rectangle. So you can go to this back side. So what's that one? Well, that one is going to look like this. It's going to be 11 centimeters here. This part is going to be how much? Well, it's going to be the same as this guy. So it's going to be 24 centimeters. It's a rectangle. Just like you see here, when you take this apart, this is a rectangle. So that was our front face. Then we have this guy, and we have this guy. So that rectangle, we know, must measure 11 here, which is right there, and it must measure 24 right here. So it's just going to be 11 times 24. We know that 10 times 24 is 240, and one more 24. This is going to be 240 plus 20, 64. 264. Also, when we're multiplying by 11, I don't know if you remember, but when you multiply a number by 11, you write that number down outside, you add the 2 numbers up for the inside. So that's a way to calculate multiplying by 11. 264. So now we have 264 centimeters squared. That's this rectangle. And I really encourage you to draw the rectangles the way that you see them here to help you make sure, did I get all of them? I've got 2 triangles And you can even draw those guys and say 2 times that. I've got this guy, I've got this guy. Now what do I have left? Well, I have this one left. 17 centimeters. And it's gonna go down in the back, the part that we can't see. And this is gonna go down, and then this also, of course, will be 17 centimeters, because right here would be 17, because it's the same as that guy. What is the other part here and here? Well, again, that's gonna be 24. That makes sense, because all of these sides are the same. Just like you can see here, otherwise you'd have a weird shape that would go like this, and it would no longer be a rectangle. So these edges must all be identical. Okay, so now we have to multiply 17 times 24. All right, how are we gonna do that? Well, sometimes I notice that you guys really like the box method. So if we did that, we'd go 10 and 7 times 20 and 4, because that's 17 and that's 24. So 10 times 20 is 200. 2 times 7 is 14, but it's 20, so it's 140. 10 times 4 is 40. 4 times 7 is 28. Now we add them all up. 200, 300, that's 340. Plus another 40, that's 380. Plus 28. So let's double check. 200, 340, 380. Plus 20 would be 400. Plus 8, 408. Another way you can do it is this way. 4 times 7 is 8. 2, 4 times 1 is 4, plus 2 is 6. 2 times 4 is 14. 2 times 7 is 14. 2 times 1 is 2, 3. This is going to give you 8. 6 plus 4 is 10, 408. However you want to do it, I know a lot of you will use a calculator, but again, it's good for your brain to do it that way. All right, but no matter how you do it, in the end, 408 centimeters squared for this shape, this rectangle, 408 centimeters squared. So to find the surface area of this, you should have 2 triangles and 3 rectangles. We have 2 triangles, we have 3 rectangles. Add them all up, you'll get your total surface area. Okay, now let's try a cylinder. Okay, with a cylinder, you have to imagine that you're doing the 2 discs plus the wrap. Okay, so I've taken a cylinder and I've opened it up. Before, it looked like this. Okay, so our 2 discs, let's start with those. So one disc is going to have a radius. We measure and we get a radius of 3.25 centimeters. So the area, the surface area of a disc is going to be pi r squared. So we have to square 3.25 and then we multiply it by pi. Okay, well, I did that already over here. So our diameter was 6.5. Half of that will be your radius. Square your radius and multiply by pi. 3.25 squared is 10.5625, and that times pi will give you 33.18 rounded centimeters squared. So that number right here is your surface area of one of your circles. Okay, one of your discs. So we're going to need 2 of those. So you can go like this, and then you'll have your total. So you'd have 66. Oh, sorry. You'd have 33, I'm skipping a step, times 3.18 times 2, or plus itself, because there's 2 of them. 18 and 18, that's going to give you 36. So we're going to leave our 6 there, and it's going to be 66. So 66.36 centimeters squared. So that's 2 of them, okay? So actually, maybe we shouldn't put the cloud around this guy, because that's not what we're going to be adding up at the end. We're going to be adding up that guy. Okay, what about the wrap? Well, sometimes you'll know what the wrap is, but what if you don't? How are you going to figure that out? Well, you can do circumference. And circumference is the diameter times pi. So our diameter, if we know that the radius is 3.25, we double that to get the whole way across. So that is going to be pi times the diameter, which is 6.5. So 6.5 times pi that'll give you your circumference. This will be equal to the circumference of this guy. Then you're going to multiply that by your height, or your width, or your length, whatever you want to call it. So if I had already figured out that my circumference, if I were given the circumference, so the circumference we're going to say is 19.8 centimeters, and that's going to be multiplied by this. So this guy times 21.5. And that is going to give us 419 centimeters squared. And that is what we will add to this guy to get our 2 circles, the surface area of those discs, plus the surface area of the entire wrap. And when you take that surface area plus these 2 surface areas and you add them together, you get the surface area of your entire cylinder. But once again, if you're not given this 19.8, you can use your formula for circumference, which is pi times the diameter. Because we knew that the radius was 3.25, we just double that to get a diameter, so it would be 6.5. And then we multiply that by pi, and that will give us our circumference. And the circumference, last time, the circumference, why is that important? We, yes, need the surface area of the entire disc, but we also can use the circumference because the circle is just that length of the wrap. It is equal to that because we've just unraveled it, unwrapped it. So I hope that explains your cylinder. Now let's try a couple of problems. Okay, the last thing we're going to talk about for this unit is the surface area of composite objects. So what does that mean? It means, for example, if you had a cake, a double-decker cake, and you wanted to calculate how much icing you're going to use. And you just didn't need the bottom, but you did need to know how much icing you would put all around here and on this part and on the top. Or if you were going to paint a house. So you need to know, let's say it was a wooden doghouse or a birdhouse. So you'd need to know all of the surfaces that need to be painted of your triangular prism and your rectangular prism. So let's break that down. Okay, what do we need to know? Well, if you can imagine, let's start with our cake. Obviously, you're going to need to calculate the wrap. You'll need the wrap of both of these cylinders. And if you remember, the wrap is just the circumference, opened up, times this height, which we sometimes say length and width for a rectangle. So your wrap ends up being a rectangle. You have 2 of those. Plus you're going to need to know weight. What? Well, we're only going to put icing on this part right here. We're not going to put any in between the 2 layers. So if that's the case, then how can we calculate that? Well, you could calculate what that would be and calculate what this would be and then subtract the overlap. That would mean you'd have to subtract that amount here and also that amount here. Instead of doing that, what if we could imagine the part that we would cover here would be exactly how much is missing? So we could just imagine that we're going to cover this, but take that central part whoop, and put it on here. So really, all we have to calculate is this green part. Because the green part, if you look at it like this, and you imagine, it's just going to be the top of the small cylinder and this part of the larger cylinder. So if we were to put those together, what do you get? This. So all you have to do when you have an object like this is calculate that whole thing, and then you have to calculate the wraps. So you have to calculate the outside around of this guy, the wrap, and you have to calculate the wrap of this guy. Now if it's something that you're asked to calculate the composite object, the surface area of all of it, including the bottom, then you would simply have 1, 2 discs plus 1, 2 wraps. What happens in an actual question? Let's do one. So here's a question. If you had 2 cakes, and this was 14 centimeters across, the height of this cake was 5 centimeters. The height of this cake was also 5 centimeters. The circumference, if we could imagine that we could see the bottom of this, or the circumference of this, would be the same thing, would be bisected by our diameter, which is 26 centimeters. So we have this diameter of 26 centimeters. So if we were to look at the very bottom of the cake, it would be a perfect disc with a diameter of 26 centimeters. Okay, great. So the top one would be a smaller disc, and it would be 14 centimeters. And I find it helpful to draw things on the side to remind myself what I'm actually calculating. But here's the thing. In French, we say the chevauchement. In English, we say the overlap. There's this overlap right here that you're not putting icing on. You're not putting icing on the bottom of this guy or this part of the top. But this is equal to this part. So if you just imagine smushing that down into one cake, you're really just doing this top disc in total. And you just take that icing that you don't need for the bottom of it, and you plunk it on here. Okay? So if you can imagine, okay, what do I need to ice? I need to put icing here and on here. And that happens to be the exact same as just doing this. So how do we calculate this? Well, if we know that the diameter of this guy is 14 centimeters, that means that its ray, or en français, rayon, would be how much? Well, we know that that's half. And it goes out in every single direction, and they're all exactly the same. So that would also mean that would be half of that. So the radius is going to be 7 centimeters for that guy. What will it be down here? For this guy, it's going to be 13 centimeters. Because it's half of 26. Okay, so now we have the information that we need. So what should we do first? Well, if we do pi r squared, we are going to get all of this. And then we could do this, and we could subtract this part that we're not putting icing on, and the bottom of this guy that we're not putting icing on. But instead of that, we're just going to calculate what it is for this. Okay, so we have 13 squared, which we know is 169. And we're going to multiply that by pi. 169 times pi. And then that'll give us all of that. What else do we need to know? We also need to know this wrap and this wrap. So what is this wrap? Well, this is going to be the circumference. That'll be the length once we take this part out and we lengthen it all the way into one long rectangle. This is the circumference. So how do we find circumference again of a circle? Well, if we know that the diameter is 26, we multiply the diameter times pi, and that'll give us the circumference. And that value of 26 times pi is this. What is this? this is 5 centimeters. So then we can calculate the area for this. So we have that wrap. What about the smaller wrap up here? Now remember, this would actually be this whole thing. So what you're seeing here is this little cake, and this is the part that you're seeing here. But what we want to know is what happens when we stretch it out like this. So that's what I'm talking about over here. So how long and how wide is that part? Well, this is going to be the diameter, which is 14 times pi. And the height is 5 centimeters. So we have to multiply this times this times this to get the area here. And we have to multiply 14 times pi times 5 to get the area here. Why is that? Because this length is equal to the circumference. So this length is 26 times pi, and this whole wrap, the length will be 14 times pi. And then we just multiply it by this, because it's length times width. And the width in both cases is going to be 5 centimeters. Okay, once we have the two wraps, and we know how much this is going to be, we have the whole thing calculated for how much we have to put icing on it. Add them all up, and the total area, the total surface area for icing will be 1,159.25 centimeters squared. So if you were trying to price this out, or you're trying to make enough icing, you could say, well, I need about 1,160 centimeters squared, and I'll for sure have enough. Okay, for our last question, let's look to see what happens when we put a triangular prism on top of a rectangular prism. Well, it's all the same. These questions just take a little while, but if you think about each surface one at a time, and you keep track of what you've calculated and what you haven't, then in the end, add them all up, you're going to get the right answer. Okay, so let's have a look at this guy first. How do you want to do this? Do you want to calculate this whole triangular prism, get the answer of every single thing? So that would be the front, the back, this guy, the bottom, this side over here, and then subtract the bottom, because we know we don't have to, like if we were going to paint this or wrap it with wrapping paper, we wouldn't do this bottom part. So you can subtract it from the total, or you can just not add that into your calculations. It's up to you how you want to do it. Then we have to figure out our rectangular prism. So again, rectangular prisms, we know we can go top, bottom, front, back, side, side. If we do that, we're going to have an extra part here that isn't getting painted or wrapped. So then we have to subtract that at the end, or we just don't add it in the first place. So it's totally up to you how you do this. The first thing I would suggest to you to do is make sure you know what every side is. So we know this guy is 8 centimeters. That means that's also 8 centimeters, because this is a rectangle. And we can see that because there are 90-degree angles. If this is 4 centimeters, this is also 4 centimeters. If that's 4 centimeters, this is 4 centimeters. Why is that important? Well, here we know this is 10, but we don't know what this is. Now, in the question that we gave you as an example, it does tell you that it's 6 centimeters, but I wanted to show you a strategy so that you could figure it out, even if we didn't tell you. So 4 plus what is 10? Well, of course, it's 6 centimeters. What else do we know? Well, if this is 3, this is 3. Well, if this is 3, whoop, up to the top of this rectangle, this is going to be 3. If this long side is 10, this also will be 10. Now, we may not even need some of those measurements, but at least now we know every single side, and we're not going to get confused and put 3 centimeters here or 4 centimeters here, which often happens. It's one of the most common mistakes I see. Okay, so now what do? Well, let's decide how we're going to do this. Maybe you want to start with some color. So that's a rectangle. What's that? Whoops, does it look like a rectangle, Mrs. Carpenter? Okay, what's that going to be? That's going to be 10 by 3, or 30 centimeters squared. Do we have any other faces like that? No, because this is a right angle triangle. But we do have something right here. So that back part that we can't necessarily see very well, which is kind of like this, on the back right here, that's going to be your 6 centimeters by 3 centimeters. And it's also going to be a rectangle. So if you can envision that. Like if I had this guy, this is not a right angle triangle, but if you can still imagine that this is your front face, we've already done this guy, so that's going to be a rectangle. Then we have to do this guy. All right. What's 6 times 3? Of course, that's 18. So we have 18 centimeters squared. So far we have 30 centimeters squared, 18 centimeters squared. And again, it's up to you how you're going to keep track of it. I'm going to go like this because I know I have to add these numbers. Okay, what else do we have to have? Well, a triangular prism has this, the bottom, but we don't need to calculate the bottom because we're not going to be using that part. And then it's going to have, so we've done this guy, we don't need the bottom. What else do we have to have? We're going to have the back and the front. So the back and the front are going to look like this. I find it easier to draw them because then I go back and I say, oh yeah, I don't need that. This guy, nope. Did I get this? Yes. Did I get the back? Yes. Did I get, or I should say the side, did I get the back? Yes. Did I get the front? Yes. Okay, so we're gonna have two that are the same here, but what do they measure? Well, a triangle is base times height divided by 2. But wait, we need 2. So I'm just gonna do base times height. The base is 8, the height is 6. Because it's a right angle triangle, we don't have to calculate what the height is, it's given. So 6 times 8 is 48. So 48 centimeters squared. That's the two triangles put together. If you want, you can say I've got 6 times 8 divided by 2. Each one is 24. And 24 plus 24 is 48. Whatever makes the most sense to you. Okay, so 30 plus 18 plus 48, that's going to give us all the sides that we have to cover. So for just the triangular prism, it's going to be 30 plus 18 plus 48. 30, 18, 48. This doesn't count. So you can add those all up. So I've got 8 and 8, which is going to be 16. I've got 30 plus 10 plus 40. This is going to be 40 and 40. So we've got 96. 96 centimeters squared. So that is the surface area for the total that we need. Okay, what else do we need? Well, we need the rectangular prism. Okay, rectangular prism, what's that going to give us? Well, let's use a different color. Let's get out some green. I can't find green. Okay. Looking, here we go, green. Okay, so the rectangular prism, remember, is top, bottom, front, back, left, right. Oops. What don't we need? We don't need the bottom. We only need the top. We still need the front and the back, and we still need the left and the right. This will make it easier for you. So what is the top? Well, the top is going to be 3 times 8. So the top is 24 centimeters squared. What is the front and the back? 3 times 4, front. 3 times 4, sorry, the left and the right. Mistakes are good for our brain. 3 times 4 is 12, that's the right, and 3 times 4 is 12, that's the left. 24 centimeters squared. Awesome. Okay, what about the front and the back? We have the front, 8 times 4, and the back, 8 times 4. So the front, 8 times 4, 32, and the back, 32, is going to be 64 centimeters squared. So now we have to take all of those. So it's going to be 48 plus 64. 8 and 4 is 12. 4 plus 8 is 12. 60 and 40 is 100. 112 centimeters squared. And what is that? That is the surface area of this whole box without that. So then you take the 96 and the 112, you're going to add those together, and that should give you the surface area of the whole thing. So you were going to have 208 centimeters squared. Now again, if you wanted to do it, you could do separately the triangular prism and then the rectangular prism and subtract the two parts that are stuck together that are the overlap. And taking those away, then you would get this same answer. I find it easier to know that I'm not using those and to make sure that I don't calculate them in the first place. But if you draw it out and you keep track of everything that you've done, whether by drawing what you're doing or writing it with words, then you're going to get the right answer in the end. So that is our, and label it, total surface area of both prisms, let's say, together. Or total surface area of the composite object. I hope this has all helped you to understand surface area of 3D composite objects way better.